Alright, here we are on part 3 now. I know it's been 2 weeks since part 2, but that's okay. It doesn't matter. We're going anyways. So the first thing we're going to cover multiple different things, but the first thing we're going to cover is variable. Now, I just opened up a script. If you remember, I was referring to, I don't remember what exactly I named it, but I named it something along the lines of this. And I used it in episode 1 or 2, I don't remember which one, and I called it shortcut, but these are really variables. What I'm doing is I'm creating the variable a, which is also just think of it as shortcut for script.parent.parent. We already covered that. But it doesn't just have to be instances in the workspace. It can also be your own things. It can be set to true, false. It can be any value possible. Anything you could possibly set a value to, like have any properties. Let's go through head real quick. Let's look at this brick and see the different properties. Brick color can be a variable. Materials, numbers, like reflectance and transparency, use numbers. Names, parents, all that can all be, these are strings. Name is a string. So let me just show you that real quick. So that's what's known as a string. Anything in quotes like that. So variables just refer to anything. So let's make it a string, call it new name, and let's just change script.parent.name is equal to a. So this is pretty self-explanatory. We take the script, go to its parent model, its property name is then set to a, which is set up here to new name. And it works. It's a pretty basic thing. You can set it to numbers as well, and this should also work. Yep. So what variables are used for are keeping track of things. So we can actually set it to nil. Now that nil means that there's nothing there. So you're saying a exists as a variable, but it doesn't mean anything. So we can write a function here. Whoops. So let me just finish writing this. So if we make a function called set and then call it later, inside the function, it'll change a, which is currently set to equal to nil. It'll set it to pi, so it'll set the script's parent's name to a, like that. Now, if you might be asking yourself why I put local in front of this. Now, it's not going to change anything right now if I don't put local in front of this. Let me just change the name real quick to SSS. It doesn't matter. See, it still works. But the thing is, what local does is it basically establishes that this is a variable inside this whole thread, and the current thread is the entire script. But if I did this, if I set a variable local b inside of set, well, set, the function, is its own thread, and this variable local b is only set to this thread. So it doesn't exist in the whole script, it only exists right here. So if I try to call this, it'll error. And there's the error right there. It says got nil, because when it tries to refer to b, as you can see with the blue underline here, b isn't established anywhere except for inside this function. And even though we call this function, b still only exists inside of it. Now, if we got rid of the local inside there, if it never has local, it just assumes the entire script is the thread. So it'll work now. So that's how localizing variables work. I'm sure there's wiki articles on it. It's kind of an important thing to figure out, and it's used quite a bit, actually all the time. Variables are very important. Now, the next part of variables, let's make this a number again. Variables can obviously be changed and manipulated, just the same way we do a property. So we can set a, the variable up there, equal to itself, so 5 is equal to 5, and then plus a number like 2. So let's just change this to a real quick. This should make this 7, if my math is right. So you can still change variables and everything about them. If we make this have like 5 or 8 in there, and remember this is how you use arguments. Refer to that. So we set 8. 8 is right here. 8 is also right there. Is basically how that works. And then it works right there. 13 is 8 plus 5. So variables, use them for storing information or anything like that. Moving on from variables, we have if statements, or conditionals I like to call them, but let's call them if statements because that's what most people call them. And they're a pretty basic idea. How could I write this? Well, we can say if a, what is this going to be, 13? Then this is pretty simple. You write if, then you write the condition, you write then, and you also put an end at the end of it, but look at this, it'll do it by itself. It'll make an end for you. And then you put whatever you want to happen if this is the correct idea to happen in between the then and the end. But there is other things you can do instead of equal, which is basically the same thing as equal. But if you use one equal, it'll error itself. So always use 2 when using an if statement, always use 1 when setting something, as I'm doing right there. But the other options are a tilde and then an equal, which means not equal to. You can use greater than or equal to, less than or equal to, less than, or greater than. And those are the really basic math ones. You can also just do if a then, so this is if the variable a exists at all, which it does, then do this. Or if not a, if a doesn't exist, do this. So this is a good way of checking if something exists. So if you do if script.parent, or if script.parent then, so like if the script's parent exists, do this. Or if you're looking for a specific thing inside the character, like let's just assume there's a character. So if the character has a head, then do this. Find first child is also very important for if statements. If you ever want to reference something in Explorer over here in the workspace and checking if it exists, you're going to press : type find first child, and then the name of it, like that. And what this will do is it'll find that child, and so you're checking if that child exists. You're saying if you find this child, then do that. You can also put not in front of this as well, of course. If not, find name. If the character doesn't have an object inside of it called name, which it currently doesn't, then do this. Now, if car find first child name does not refer to player's name, that's not this name. It's if there was an object in here named name. Also, one tip about find first child, it can be written with a capital F for the first F or a lowercase one, but the second one is always capitalized and the C is always capitalized. Now the next part we're going to work on is returning in functions, and basically what this means, when you call a function, the last thing the function can do, like there can't be anything after it, is it can return something. So it can return a variable. So local b, only existing in this thread, is equal to a, which is up here, plus the number given right here. And then it returns b. So how that works is you set something to it. So a is equal to set 8. So a, which is currently 5, then becomes this 8 that is sent here and then here and here, and 5, which is already known, becomes b. So a becomes b, and a would then show up as 13 again. If that one was a little bit confusing for you, here's another one. We're going to get rid of this altogether and write script.parent.head.brickcolor. Let me just get rid of this. We don't even need this right here. So what this does now is it says col or cull is equal to sets return, and set returns script.parent.head.brickcolor, which is right here. So this is going to change the name of this to medium stone gray. Oh, hold on, it didn't work. Yes, I forgot. We were trying to set name to a brick color, and as we can see, brick color is a brick color value because it has this pop-up, while name is something we can type in, so it's a string. So the option, we'll learn this maybe sometime in the future, but if you write something, wrap something in the toString function, so basically writing toString parentheses, whatever you want, toString, end parentheses, it's going to convert this to a string. So now it'll work. If you don't know how toString works, just look it up on the wiki. It's pretty basic. As I said, functions can return something, and if you remember in the first episode, every instance, such as a part, has events in it, but it also has functions in it that you can call on the part itself. So if we go over to the wiki right here and go to a basic part, as you can see here, we scroll down, we see all the properties it has, all its values, like I said, and at the bottom it's all the events that it has and how they work. But there's also functions, and these are things you can call, and sometimes they return things or sometimes they do things. So the first one here, break joints. What this one will do is it'll obviously delete any welds or any kind of connection it has to any other parts, or make joints, which is the opposite. But something that returns something is get mass. So if I called get mass, it would then return a float, which would be basically means a number. And what it returns, if we click on this, it shows returns float, returns the object's mass. So let's call it real quick. Let's just say script.parents.name to script.parent.head get mass. So how do you call a function is always with 2 colons followed by the name followed by 2 parentheses, and if there's any variables involved in the function, you put them in here like this, but that's not important. This get mass does not have anything besides emptiness in between its parentheses. So 5.599. It goes really far in the numbers, don't worry about that, but that's basically the mass of this. The point is, though, that when you call get mass, it returns the number of the mass, and we can set the script's parent name, which I'm using to show you guys what it is. Let's get another example here. This one I won't do because it'll actually break the game, but I went to the player object, what joins the game.players right here, and this has a lot of different functions. Get mouse returns the mouse of the player, so you can use it to detect button inputs or keyboard input. Kick obviously kicks them from the server, and here it has a little argument you can place inside of it as a string message, and you can say kick parentheses bye. So if I showed that, it'd be like play kick bye bye. This would, if play was a variable assigned to my player right here, and I called this, it would kick me and then show me them. Yield functions are basically the same thing. I'll just notice those real quick, but they take time. So if you call this, it'll usually send a request to the website, like get rank and group will send a request to the website to see what group rank they have in whatever group you specify right here, and that'll take time because it's sending like an HTTP call and stuff to the website. And so yeah, always check the wiki for functions, yield functions, and events. Now we're actually finally on the last part of this one because this took a really long time. The last part here is creating your own instances. This one is done all the time. It's basically if I went to here, I inserted a I don't know. Let's just do a part because I like working with those. I'm going to insert a part into workspace. I'm going to change its color to navy blue, and I'm going to make it fully reflective. All right. So instead of doing that manually, because you can't obviously use the Explorer in game, we can do it with a script. So first we have to establish the variable that we're going to make it. So P for part, it doesn't really matter what you name it. You type instance.new, just like that, 2 parentheses, and in here in strings, in a string format, you want to type the class name or the name of the instance. So a part, like my arm, its class name is part. So we will insert a part. Or a player is actually a model. This is also a model. We can't insert this kind of player, but it exists as an instance either way. So now we've created that. It's in the memory. It's stored. Now what we can do is we can change its properties. So let's just use the head that we have here and pretend just as a reference to see what we're editing. So we set its brick color because that's the first one, and I believe I set it to navy blue. So how we do that is we simply write navy blue in quotes for the brick color.new, because that's how you instance, or that's how you reference a brick color value, is you write brick color.new, just kind of like instance.new. The next thing we have to change is we made its reflectance 1. That's really simple. You just write p.reflectance equals 1. Now we also made it inside the workspace, so that's the last thing you want to do, is you want to put it in workspace. Now these can go in any order and it'll all have the same result, but keep in mind that scripts do read top to the bottom, so if the game is really, really laggy, it'll parent it to workspace as a gray default brick, then change it blue, then turn its reflectance to 1. But that is if you were lagging really bad. So that's really how you create an instance, but let's just go a little bit further. I mean, this is going to make it in workspace, but it's going to put it in the default position too. So let's just make it on top of our character real quick. So if we set its p.position, which we can see is an existing thing, to, let's say, our character's head's position, game.workspace.player1.head.position. Now because this is a position, not a C-frame, it'll actually try to find the nearest point on top. If I tried to set its, I'll do that in a minute actually, I'll just show you. It'll probably go by really quick though. Whoops. It moved my camera in, but it is above me, and it is following the rules of navy blue and reflectance of 1. What I'm going to really quickly do is also change these properties as well. Hold on, let me put them in front of workspace like I said to do. I'm also changing the properties can collide and anchored. Can collide is like can players walk through it or look through it, and anchored is if it moves in place. So let's do that again. See how it creates the part exactly at my position here, my head's position. But it's not rotated to my head's position. What we use that for is then C-framing, or coordinate framing, but I'll probably do a whole thing on that because it's super complicated. But that keeps the rotation of my head as well. As you can notice, it's now directly aligned with my head. No matter where I move it, it'll be aligned with my head. That's really it for this. I went over those 4 or 5 topics fairly quickly, I hope. Really generally too, but now that the 3rd episode's done, I'll be able to address certain things that people put in comments and such, and I'll make a video on suggestions, and I can get more in depth with different kinds of scripts, more advanced scripts. because now everyone has an idea of the basics. Even if you haven't mastered them, I know a lot of people have, but even if you haven't mastered them, I'll be using them and referring to them a lot in the future. So, yeah.